Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products. 3, 2, 1, let's go. Hey everybody, welcome to Beyond the Bench, where we tell the stories of taking hardware products to production. Very special episode here today. I have myself, Bill Brock, CEO of Peridio, and then also with me are my two co-founders, Justin Schneck and Daniel Spofford. And we're going to do a little bit of a freeform riff on Peridio, who we are and where we're headed. So I hope you all enjoy it and excited to dig in. So we'll go around the circle first. And Justin, why don't you go ahead, introduce yourself, a little bit of background, and then we'll kick it over to Daniel.
Hi, Justin Schneck. I've been doing embedded systems for way too long. Not really. Never long enough. It's a lot of fun. It's a lot of pain, but that brings a lot of the joy and the fun out of it too. I all started back when I wanted to be able to remote start my motorcycle from my phone, and that kind of like brought a software career and a hardware, and realized that there just wasn't enough out there to be able to make it easy for other people to kind of follow the same pathway. So started working on co-authoring a framework called NURBS. Graduated that into making a lot of friends and commitments into the Elixir and Erlang ecosystem. Worked on some stuff deep into the Linux kernel. Spent some time shepherding others through some work with the Erlang Ecosystem Foundation, and had a big stint with you guys together, shipping a bunch of products and helping a lot of people, companies be able to build better products themselves as well. And that led us here to have some strong opinions on some OTA and devices, managing them in the field. So yeah.
Awesome, thank you. And Daniel, the thread that binds us, Elixir development. So maybe a little more your background, but thanks for coming on, Daniel. Who are you? Where have you been? And where are we going?
Yeah, Daniel Spofford. Where have I been? Fargo, North Dakota. I was born there, so I've definitely been there. I've been doing software since as long as I can remember. My background was more like very early, like 13, 14, playing video games, and then getting into modding and programming through that. That was like a lucky on-ramp for me to get started quickly. Loved that. I loved both like the fun output of it, but also the like the rigor and the correctness and the creativity that can go into it. I really fell in love with what you can do with software. And then, hey, I found out you can make money writing software. So then the rest of my life was set and figured out. And yeah, I've been investing in that path since then. So over those years, I guess I have done connected products, done a lot of consulting, done a lot of IoT devices. Like I said earlier, it was like more software focused, but sort of in the middle of my trajectory, I did start to touch hardware and collaborate with like EEs and mechanical engineers and bring those connected products to life. And that was a really interesting like clash of efforts, because especially if you're like consulting with a company, the mixed pressures of wanting to be correct and do the right thing and have it be cool and sellable and people want it, but also like the timelines and the constraints that come on top of that, and then finding a way to thread that successfully, especially with diverse teams. All of that smashing together is kind of what pushed me in this direction of what eventually became Peridio, of how do we navigate those mixed concerns effectively and quickly. Where is the friction in making connected products, and how can we be better there?
Awesome. A little background on me, Bill Brock. I am I'm the least important or interesting person here, technically speaking, but I have a lot of the customer conversations and develop a lot of external relationships and partnerships. The way that I met these two individuals, the both of you, was through our time at Very and consulting. And when we first started Very, or when I started at Very, it was like 9 years ago. Prior to the spin out of Peridio, we were a general purpose web development company. My background was mostly in software development, a little bit of math here and there, but did not want to spend my time in the basement of a research lab, so started working more with entrepreneurs and startups and all of that. And while at Very, we got introduced to the Elixir programming language, Phoenix framework, all those things. That led me to meet Daniel through some online recruiting activities, and then we started just getting interested in exposure to hardware programs, and then Elixir plus hardware was the segue to Justin Schneck and the Nerves project. So I think I made the comment earlier, Elixir being the thread that binds us. It definitely is, and curious if we could just take a quick sidebar, even outside of hardware, and talk about why Elixir, because I think that was that was one of the first like watering holes that brought us all together. So either of you want to pick that up?
Well, first, Bill, don't sell yourself so short. You dabbled in some high performance computing in the past,
I
and that
dabbled in
stuff is
some.
hot.
I
That's
did some
hot these
That
days.
MPI,
HPC.
some MPI for a minute. I did
Yeah,
grids. Made some pretty pictures.
yeah,
It was fun. It was fun. It was not commercially valuable. It was the pace of research was a little slow for
yeah.
me. I'm more of a I like to be a masochist in the markets rather than the research side.
It feels very happenstance, or the statistics of it are crazy. Me getting into Elixir and how. So like I think I made a joke about being from Fargo, right? And there's a lot of agriculture there. There's a lot of ag tech there. There's a lot of
And snow.
technology. Microsoft has there's origins in that area. It's not, yeah, there's snow too a little bit. But my intro, like a lot of the times when I talk to people about Elixir now, they will say they hopped on, as it was sort of like being compared to Ruby, as like the evolution of web
Me.
stuff was happening, yeah, in Elixir, and that's like a very common story for folks that use it. Mine was like a little bit more traditional. Like Erlang and Ericsson is like phone stuff. It's like telephony stuff, and I happened to be what I did in Fargo. As I worked for a company that was doing like real-time call center dashboards and telephony and connecting call legs and blah 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 stuff like that. And because of that, we had systems that were written in Erlang. So I got a little bit of like arcane exposure to that. It was always like, whoa, Erlang, what's this weird syntax, was like the feeling there. We had a really cool CTO at the time though, and there was a project that we needed to do that was like back-end parallel performant processing of stuff related to calls. And we were like, hey, Elixir's this thing, this pre 1.0 thing. Can we mess around and have a good time in like a little, controlled box setting of it? And, he said yes. And we did, and it worked really well, and it was a fun experience, and all of the sharp edges were sharper, but it was cool. And yeah, that was like my that's like how I got in, and I loved it. The moment that I started using it, it was my exposure to like functional programming, immutable data structures, and like all of the things that come with that. It was a very pivotal moment, I guess, in my life.
Yeah, that hard switch between the object-oriented mindset and the functional programming the first time you make it. But then it's kind of like when you see that movie that was really good for the first time, but then all the subsequent times you watch the movie, you're just like, yeah, I know what's going to happen, But to get that feel-goodery surprise that first time around, yeah, that's
I was Java and PHP and JavaScript, and yeah, I was
yeah.
very deep in that world. Yeah, it was a fun
Why
bit.
why Elixir? Why not PHP? That's not
Yeah,
what we're going to talk about today.
yeah.
Justin, how did you find Elixir, Justin? I've never even asked this question. Just you kind of like,
Yeah.
was it like your barista recommended it to you, or?
Well, like I said earlier, when I was getting started, I was obsessed. I loved technology and I loved motorcycling, and I wanted to combine those two things. But before I ended up like really dedicating a lot of time and energy into writing Nerves, I was trying to be able to work through some of the foundations that I wanted to be able to create. And originally, yeah, I reached for Ruby as well. And I just realized after some quick amount of time that Ruby just wasn't going to cut it, and that I needed something that was going to be more supportive of like a process model. I needed something that was going to be more robust. It was going to be able to prevent error conditions, or be more robust against it. And yeah, I found myself as a naive young programmer reinventing consensus models in order to make things work, and process models in Ruby to try to make it work. And a friend of mine, he was saying to me at the time, he's like, "Oh, you should check out this thing called Elixir. It's written on top of Erlang. It's new, also pre 1.0 days, and give it a try for what you're working on." And it really had a lot of the mentality, and it's no wonder. I mean, as Daniel was talking about here, it was originally built for like telephone switching networks for hardware. It was written to run on like embedded devices, and it was really well suited for the task because like it embraces this mindset that's different from the ones that we have to deal with traditional software development strategies where you're not always having to face the unknown unknowns of like what kind of like input am I going to receive? Like, what is it going to be raining? Like are we deploying this stuff into physical reality? Are people going to have like peanut butter on their fingers when they touch the screen? And there's just so much that is unaccounted for when it comes to embedded devices. That Erlang way of programming with a model in mind of how to react to failure because failure is inevitable really resonated with me, and from that moment I just felt like that programming style was really core and foundational to building robust fault tolerant embedded devices. And I wanted to be able to not only I loved what I learned about that from the Elixir and Erlang ecosystem, but I want to be able to like make that even more accessible as a foundational element with the tools that we have in embedded Linux today, so that people can embrace that even with things like systemd, acting as a process model and manager, and furthermore just how to organize your embedded runtimes to work with different cross-language stuff and keep your system running.
Yeah, it strikes an interesting balance. Part of what you were saying at the end there ties into like my early interest that I was alluding to of software, and then also what I found appealing in Elixir, that is this like rigor. And rigor can come in a lot of ways. You can go like turbo static typing, Rust level, rigor. You can go real deep into it, which is, has its use cases. Elixir kind of has this, and there's actually just topical conversation now of like adding type systems and stuff to Elixir. But that aside, even 10 years ago, this notion of like pushing to the forefront of thought, like, but what if it fails? You should consider that. It will fail. It's not, well, I hope it doesn't fail. Well, that's not the type of systems that I find interesting. That things in reality, things that people actually use, whether that's physical or not, they fail. And I personally liked the amount of rigor when someone would care about that and try to account for that. And it was nice to see a language that sort of like facilitated that and pushed that to the forefront of thought and gave you ergonomic tools to handle that. That was like, yeah, a big part of the appeal.
Yeah, and it's definitely not for everything.
No.
If you show a firmware engineer who does microcontrollers for a living Elixir, they'd be like, "That's great, but it's like a million times too bloated to what we can use, for our designs." And even so, they still need to be able to reach for low-level language tools to be able to do things like drivers or high-speed interrupt when it comes to embedded devices. But man, is it a great control plane for being able to do fast switching, monitoring, like process supervision. It's just a good process model. It's a really good process model. And everything we've been talking about that we really gravitated at, that I'm hearing that we liked, was really around like the fault tolerance of the process model itself. And sure, the functional programming is cool, but yeah, the process model about Elixir and the Erlang VM is really what I found uh, quite appealing to the embedded designs.
You spent a lot of time in the Elixir plus embedded space. I don't want to detour too hard into the nerves aspect because I think that we're also going to be talking quite a bit about embedded Linux as a whole, but maybe just a quick tangent, even though it's definitely an important part of the story.
Sure. Yeah, I mean, it was a great framework for getting applications built and shipped in a comfortable way. Like embedded Linux can be quite daunting because, if you imagine it to be a pared down version of a desktop OS, and your desktop OS can run many applications, and those applications would kind of maybe, in some ways or another, maybe not talk to each other, or collectively they would exhibit like a product, like they'd be the functions of a product. Making sure that all of that stuff worked under the hood, and designing a system could be quite challenging and complex. And if I were to boil down the nice parts of Nerves into like what it really offered as a developer experience, was that you got to use Elixir and its application process model as the like runtime of your entire application and your entire device, right? So we would compile your app, and your app would be the first thing that would boot. It would basically replace systemd with a little shim that knows how to boot Erlang right away, and then load your Elixir application. And so a Nerves runtime would basically just be it was compiled a lot with build root. So you'd have a build root system, you'd have your Elixir application, they would just get jammed together, and then that would get burned down onto your target, and your device would know how to be able to stand up and boot directly into your application as fast as possible. So it really made it approachable, I think, for people who weren't traditional systems engineers and just wanted to kind of care about the application layer of what it meant to be an embedded product, like manufacturer. It was really powerful for a lot of cases where, especially during this time, we had like web development shops that had a lot of great talented web developers, software engineers, you could really easily be approached to build kiosks and use things like Phoenix in the Elixir ecosystem, their web framework, to be able to ship user interfaces that could act on embedded devices. And we leveraged a lot of this and used it at several places in some industries and industrial cases, and making human machine interfaces. It really simplified at least the approach that so a developer who felt comfortable in Elixir could ship embedded products with ease.
Yeah, there's like a buzzword, not a buzzword, but a term that I'll pull of like encapsulation, and like normally in a Java like software-y context you might hear that, but encapsulation, I'll say it in this context around like encapsulating the OS from you, the hardware and Linux. Like you want to be able to control that and impact it, and tweak it should you need to. But in those cases that you're talking about, it was really useful. It was really productive to be able to get that into place and get it working, and then not have to always care about it. That when you were trying to ship some change or be productive developing your application, that minimally, only the necessary amount had to reconsider those config settings, or whatever you might be doing under the hood, that you could sort of navigate that seam a little bit more effectively. It can be daunting walking into that space if you feel like every time that you want to tweak the color of the button on your kiosk, you're like, oh, do I have to go like recompile Linux right now? It's like an explosion of complexity, and it helped navigate that far more effectively.
Yeah, unfortunately, coming out of it, there were some rough edges to it. That I mean, everything has trade-offs, right? And so some of the trade-offs we experienced were the project really tried to be able to promote building the most minimal systems, which is great in the case of embedded. You don't like I always feel that if you were to try to take a desktop operating system and pare out all of the things that you think that you don't need, you're inevitably going to miss stuff, because there's going to be stuff in there that you didn't even know existed, that you didn't know that you had to turn off, right? And that's the opt-out approach. With tools like Buildroot and Yocto, all the stuff that's in the deep tech embedded Linux space, those force you into an opt-in approach, which is more desirable but harder to be able to kind of get right. There's more iteration timing there, and the problem with the pared down approach with Nerves meant that everything that the project was doing kind of presented the case where there was a bottleneck of tons of logs and research that were out there on how to do things the embedded Linux way, or even the
Yeah.
adapted Linux way that would work on embedded. And then you'd always be asking yourself, okay, well, how would I do this the Nerves embedded Linux way? And it would just, because the approach was so different, there would have to be a lot of your middleware was going to have to be written in Elixir, because as mentioned, Elixir and the Erlang VM were effectively replacing Systemd as the initialization system. So there was a bit of reinvention that was there, and so it made it less approachable and inevitably for people to be able to get access to the information, and made sort of the project maintain community more responsible for needing to be able to almost be a bottleneck for people getting access to this information, or even having to be able to create to recreate things that already existed in the upstream embedded Linux. Sometimes the strive to be able to make things smaller and more efficient turns out to not necessarily be like, it's certainly a great goal that we should have efficiency in mind, but the market has kind of pushed us to this place where it's like, well, does my runtime need to be 10 megabytes if cell phones have pushed the economics of multi-core processors and like 16 gigs of RAM to the point where it's cheaper to get that and have tons of space to be able to use on embedded devices? Now, like, once again, I don't want to be wasteful, but it's not like we're wasting electricity and bytes, or it's not like we're wasting electricity and resources when it comes to like bytes stored on disk. We're just giving ourselves a little bit more freedom and flexibility. And so there's a balance between both. And I think that the project for Nerves kind of overshot that balance more into the optimization for minimalist perspective, which ended up just becoming problematic for a little bit of the longer term maintainability of it.
Yeah, there's something I say internally to our team a lot of engineers, which is that we shouldn't do something just because it's cool. It's cool when you can do cool things. That is cool. But rarely is it the best idea to do something if the only reason is it's cool. And there's sort of a parallel here to what you've been saying of you. And what I was saying way earlier in this call about where, the world of like wanting to be rigorous and secure and great, like meets the reality of like budgets and timelines and companies. And like you really need to, when you're trying to achieve something outside of yourself, which most great things are achieved with a team of people. There's some like, I don't know, like Edison or someone, did something on their own pretty cool, but like
Vibe
that's
coders.
rare. Yeah. And yeah, of course. But the point is, like, you have to pay attention to constraints and goals. Like, what are you trying to achieve and what are your real world constraints? And with respect to those, if optimizing down to a 10 meg, artifact is not a constraint or a goal of yours, the chances of you making trade-offs to do that when you don't need to is pretty high. And those trade-offs are going to cost you. And it's going to feel pretty bad if you wake up one day and you notice that you have made these trade-offs in pursuit of getting something that's just cool. And now the trade-offs you made to get there are costing you in other areas where you have real constraints or goals that are being hindered by that trade-off that you made. So if you need to get down to 10 megs because you're over a metered connection and the costs require you to based off what you're gonna pull in, well then you need to and aim for that. But if you don't, like leverage different tools, leverage a different means to achieve what you're trying to.
Well, just let's move forward a little bit. So, like, what's Yocto about then? Like, we're talking about like constraints and tools, and building streamlined systems. How should people think? How is Yocto different from this?
Well, there's two main tools that are out there. There's Builder and there's Yocto. Well, I guess you could say two and a half if you consider the half rolling your own scripts that can do it yourself. But that's these days. I mean, there's just so much quality of life features that come from using one of those two tools. That kind of rolling it yourself is a little less common. But there's big design choices that differ between the two of these projects. Builder, it's really good in the case of getting you up and building for a single system quickly. But the place where I felt that it really falls short, at least in the situation where if you're a maintainer that needs to be able to maintain a distribution, across multiple platforms. Like Nerves, for example, we had a list of officially supported platforms like all your common ones, Raspberry Pi, like all the different Raspberry Pis, and like some of the stuff in the BeagleBone, the Beagle org, and a variety of other really useful single board computer dev kits as well. But when you have n number of platforms that you need to be able to build for, it starts to become a bit cumbersome when using something like Buildroot, and for various reasons or another. But really, Buildroot's also like a centrally maintained repository, and versus Yocto, which is this like composable layered build system. Now, with the composability and the layering of the way that Yocto ends up working, comes a lot of potential for confusion. And when something goes wrong in Yocto, it's going to take you longer to be able to figure it out if you're not in tune with working in Yocto to begin with than it would just in a straight Buildroot program build tree as well. But the big benefit in the case of using Yocto as a layered system is that it really it enables the like upstream silicon manufacturers the ability to maintain and own the maintenance of the board support packages, the kernel modifications, all this stuff, all the secret sauce that makes that distribution or like embedded Linux work on their boards, right? So you get usually quicker, more responsive maintenance cycles with stuff coming out from those distributors like silicon manufacturers. For example, if they're using a piece of NXP technology, NXP is going to be the ones that provide their Yocto layers. If you're going to be using TI, same thing, or TI is going to support the Yocto layers. I mean, a whole nother topic, but Open Embedded for Tegra, these guys are doing a wonderful job supporting all the NVIDIA stuff because NVIDIA doesn't actually support their own Yocto layers today. But all of that is great because in the case of Buildroot is like I said, it's a central repository, and they have to kind of like get through an approval phase, like to be able to get that bumped and updated. And it just slows a lot of the things down when it comes to getting updates and support. And you just find yourself patching Buildroot a ton just to be able to kind of get around this. So, they're both build systems. They both equally have their own idiosyncrasies and complexities. But these days, I think that Yocto really is starting to shine. It's grown up a lot. It's got a good community of folks surrounding it. And it just feels good to be able to have connected support through the layered mechanisms all the way up to the vendors and suppliers. So
there's I think funny, hopefully applicable and apt analogy that came to mind of like Yocto versus maybe versus Buildroot. It makes Yocto's like microservices, Justin. You love that one? Microservices gets a lot of talk, I'll say. It's ebbed and flowed over the years of people liking it and disliking it as an architecture, and people arguing about like what the justifications for it are. Sometimes there is a technical justification for the due to load in some area, a microservice would be more efficient to break this off, and it can operate more, blah, blah, blah. But I think the more interesting way to reason about, or a more interesting way to reason about it is it's oftentimes a human optimization. That the time that you go for microservices versus some monolith, not because of the technical like requirement, but because it allows you to have distinct teams operate on the pieces more effectively. This team can work on this part of it and ship updates with a touch more isolation. Like the blast radius of what they can control and what they're responsible for is there's a smaller box around it, and it's easier for humans to organize around those smaller circles. You can have different teams for these different pieces. And the like parallel that came to my mind with Yocto was with like your examples of the layer management. These folks are managing this board support layer, but that team over there is managing this layer for this different piece of it. And there is sort of this, just breaking up of the ownership and the responsibility and making it more effective for different human parties or organizations to collaborate and contribute pieces to it and have those be used together. It feels like that parallel kind of lines up between those two things. So hopefully I didn't
No,
sour.
it's good. It's good. But I mean, like those people still need to come together in the monolith, right? Like
Yeah,
Yocto.
yeah.
These days we've introduced a new programmer into the like persona into the group, the data scientist, right? Vibe code in Python left and right, and that's great. Being productive and producing some really interesting, compelling research and programs that we can that are like we're on the forefront of being able to step into some really crazy stuff that's going to be able to come out now. Teaching that person Yocto, it's like that is crippling in those cases. And so I agree with you in the case of the microservices concept. Like we want to be able to have flexibility of integrating things outside of those build systems. And almost to go back to why we did things the way for ease of use on Nerves project, like combining these lessons learned, people just want to treat a piece of hardware like it's a service. Like we got SaaS, we got software as a service. Like people almost kind of want their hardware as a service. They don't want to have to care about it. They just want to be able to make their application run on top of it in a normalized way. And we've been talking about complex build systems and stuff, but there is an obvious thing. Well, why don't I just install like Ubuntu on my device, right? Like I feel comfortable with a desktop OS, and there's a whole swath of reasons why that's probably a bad idea at big numbers. But because people want deterministic machines, they want to be able to make sure that things are always running the same way in the field. They want fault tolerance. You don't get those kinds of things with desktop OSs like you do with building your own in Yocto. And yeah, it just has me back to thinking like there are extra steps that we can take to be able to reach for this like kind of stuff that's like hardware as a service, And we've been kicking around a lot of these ideas internally too. So it's some extra project space that we're working on.
Tell me, like, what's the UX like in this industry? Like, what's the state of the art user experience? Like, and it's funny, we think a lot about these things and developing Peridio. We have embedded considerations, we have cloud considerations, we have a CLI, there's an API. There's just like a lot of surface area to create a good, like, cohesive experience for anybody in the platforms. But I'm curious, just like hot takes on UX and embedded. What's the world like?
The first time that I got exposed to Builderit, I'll never forget the like Jurassic Park 1 moment I had where I go into like make Builderit modifications and you run a command and it pops open. I forget the guy's name, but when he's like the and you're like seeing that computer screen, like that's what comes to mind with Builderit for me, because like you run a command and then you go through like just like expand collapse menus of like including or discluding like tools and services, and I remember just being like, this is what is this what I really have to do to like navigate this? It was just like clicking on an IBM keyboard, like paging through menus of like Linux utilities and just like, picking which ones are necessary or not and trying to navigate the like cross dependencies of them was, I don't know. The short answer would be my experience there was not great.
It's like old school BIOS, where you're like mashing whatever F key you thought you needed, like you're just moving up and down, like trying to get into BIOS, and then you get to presented that like ugly blue screen with like just text characters to make like block like images. Yeah, that's mostly the UX that you'd get if you got one. Yeah,
and it pushes you towards, at least if you're someone who like would want better, like because those were all. Eventually, I figured I was like, oh, these are all just UI tools built atop of these text files that it's spitting out, where like all of these decisions are actually getting recorded. And that's where I would drop down to eventually, where I wanted to be instead, because it felt more reliable. Like I could see it in a Git diff. I could be like, yes, I like included these 4 tools. There's a line that says, equals Y, equals Y, equals Y. Like I brought these things in or I brought those things out. So I guess that's me saying that the tools were like not very effective there, to the point that I was dropping down into like a less friendly interface, a lack of an interface, just to feel like it was a more reliable thing that I could control.
Yeah.
Well, I think rather than getting into any like upcoming product releases or big announcements. I don't think we have enough time, but I think maybe talking a little bit more about the motivations around who we are and what we're doing and what led us to spend our time in this space.
Well, the UX thing is interesting because it's all about the person, the persona that you're trying to be able to reach, right? And I want more people to be involved in embedded product development. But like the current set of tooling that's out there today is borderline unapproachable to a majority of developers because it would just require so much, it's just so much like knowledge and experience and like trial and error and like I guess the easiest thing to kind of say is like there's some people that are out there that like not looking around the room or anything, but like there's some people out there that are fine with VS Code, and then there's others that are out there that'll die by NeoVim, and that's like. And those are different experiences of user interface levels that people expect to be able to like kind of go into. And it's like some people are fine diving deep into like text documents and navigating like menus in the command line, but other people might need something a little bit more graphical to let them kind of feel empowered or understood and how to be able to do this work. Like, you know, we like containers are a good example too. Like editing a Docker file is pretty easy, but it's going to be able to like with some tooling produce some really complex runtimes that you can do testing with. But if you had to be able to like go in and check all the options in Yocto the right way to be able to get the same runtime, it would be overly complex to the person who could just do it kind of similarly in Docker. Now those are producing different things. I'm using those as like almost apples to oranges, but the process could be pretty similar. So yeah, I think like your UX comment is onto something because developers are just used to like convenient ways of being able to install stuff. You know, like on embedded runtimes, usually don't see package management, but developers are just like, yeah, well, what do I need to do if I need this? If I need like, you know, SQLite or something, I just apt-get or DNF install SQLite on my Linux machine. You know, that's not the same thing that you would do. How do you enable that in Yocto? You have to find the right config files. You have to include the right recipes. You have to build that with the right image. You have to make sure it's configured the right way. You might need to do machine-specific overrides. Like, you know, that's all in pursuit of some greatness, but it's going to feel like a mountain to the developer who has seen this better life already. You know.
I think of it in two big swaths. There is like what we've been talking about most recently, the OS, the build system, you know, what's running on the device, being able to compile that at all, being able to compile those pieces together, being able to produce an artifact or artifacts of those things that you would push to a device, all of the the tools and the pain and the stories that are relevant to that half of it. And that's only half of it. And once you get there, now you have to, hopefully you get faced with the other half of the problem, which is, hey, I actually have devices. And maybe an even better problem, I have more than one device. I have customers, dare I say it. And I have a lot of customers, and I want to be able to not ship an artifact. I don't want to flash one time to this thing. I want to be able to update it over time. I want to be able to update groups of these things over time, disparate groups of these things, override individual devices within those groups, be able to track and see what's going on with all of that. There's like this whole tail end. I shouldn't say tail end because it's relevant up front too, but it scales as the timeline moves forward is maybe a better way to say that. But there's similar pain on that side, I guess, and that's where like some of our our fleet functionality will come into play there. But and Bill, you're asking about like UX, I think that it's important to focus. There are mixed personas. There's diverse teams that are necessary to produce connected products. Whether they're like locally connected or actually connected to the cloud, but it's a diverse team that is required to achieve that. Oftentimes that's like EEs and MEs. There's data scientists, there's software engineers, there's designers, there's product managers, there's QA. Mm-hmm. There's an annoying CEO somewhere, trying to get you on a podcast. Like there's all sorts of stuff, going on. And these are all like important, relevant, real world pieces of the puzzle. And what we're trying to do here at Peridio is you can zoom into any one of those personas and go, here's 100 things of like why their life sucks and how it could be better, and they are worthy of pursuit. And it is worthy to pursue those things, and we are, but it's also important and a whole nother like paradigm shift to try to consider the wider team. It's one thing to build a tool that's purpose built for one persona. Oftentimes it's a paradigm shift if you go, yeah, I want to solve for that persona, but these personas as well. And this tool should be like effective and collaborative and allow them to all operate efficiently together. And that's like a big focus of what we're thinking about every day from like a UI UX point of view is how do we expose these things? How do we allow people to safely collaborate to get the information that they need, where they need it, whether you're elbow deep in Yocto or whether you're like, eyeball deep in a dashboard trying to figure out like projected device growth.
Yeah, I think it's funny. We've actually spent more of our time on the non-technical users, to be honest, and we're going deeper on the Linux side now, but and we've always been deep in the embedded as well. But just as far as like platform investment, it has been more on the high level and some support for the lesser technical users, and it's really cool. And in my role in talking with customers and onboarding partners and these people that like find themselves in the embedded world, whether it's a program manager or a mechanical engineer. And like I was talking with a mechanical engineer with an ME background a few weeks ago, and they're just like grilling me on all these like certificate management questions. And he's like, huge disclaimer, I have no idea what I'm doing. And then we get into it and I'm like, man, you have come a long ways. Like, you know more about this than I do. And it's just funny. Like, I don't think there's a lot of formal schooling in the embedded space. One of our good friends is a professor at the University of Colorado, and he teaches a master's program that does Yocto-focused work. But it's crazy that you have to get a master's degree to even get started in this space. And there's not a lot of, I think maybe like computer engineering or electrical engineering might get you there, but it is definitely a whole like field and world where people are having to just pick it up as they go.
I'll speak from my experience, both academic and industry experience. So there's much I don't know. I guess I'll give that disclaimer. But you really have to get lucky. If you try to attack this from an academic point of view, I think that it is like, I don't know, what state were you born in? It's like what are your parents and what is your like socioeconomic background? There's like a number of dice rolls that go into it. I'm just trying to speak to, this is not some, you can go to any high school across the country and you're probably gonna get like a social studies class or like you'll get like a chemistry class. There's not that level of like exposure or proliferation of anything in this area. Like the chance of you going to a college and there being like, hey, we're going to like perfectly prepare you to be an embedded developer with a background in like Buildroot and Yocto and how Linux works, and you're going to be able to navigate that successfully is like not something that people can rely on. You either have to get lucky or specifically seek it out, because programs do exist, like Dan, he's putting good content out there, but we need more Dans.
Yeah, or it's a statistical representation of how many Franks you know. That is also another common space. Yeah.
There's also good courses by Bootland as well to mention. They've got some good content out there too.
Unfortunately, we've exhausted the majority of our time today, and I think this is a good place to pause and just call this like an origin story episode. I would love to reconvene the both of you at a calendar invite coming soon to you for more of a like what are we up to today and what's future looking with Peridio. But this was a lot of fun. Thank you both for coming on. Anything you want to leave us with? Justin, I see you have a sentence you're wanting to say. I can tell you're like, man, I wasn't ready for it to be over.
Well, I'm looking forward to being able to make embedded development more accessible to more people, and I think that hardware as a service really is going to be a thing. HaaS, if you will. Talk about origin stories. That's naming things is a fun part. Yeah.
We'll get to the pit of that later, right?
Yeah.
I forget who I was talking to earlier today, but I was like, we used to name things after mushrooms, and now we've pivoted.
It's a short list. That's why we had I went through that list, and I was like, I can't be naming stuff like Death Angel. Like all
right. Well, we'll call it there. Thank you again, both of you, for jumping on today. This is a lot of fun. Hope everybody enjoyed the episode, and stay tuned for round 2 in a couple weeks. Take it easy.
Bye.
All right, everybody. Just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.